Welcome, everyone. Let's begin with a question. Have you ever thought about those big lottery jackpots? You know, the ones that promise millions, but then you find out they pay it out over 20 or 30 years? Well, that little detail gets to the very heart of one of the most fundamental concepts in all of business and finance. Today, we're going to dive deep into this idea, the time value of money. And I'm going to give you a powerful tool, a single formula that will help you make smarter financial decisions starting right now. So let's get into it.
Okay, to start, let's ground this in a situation you'll almost certainly encounter in your careers. Imagine you've just finished a project for a client. They're happy with your work, and they offer you a payment of $1,000. That's great news. But there's a condition. You won't actually receive the money for 3 years. Now, your gut reaction might be, well, $1,000 is $1,000, I'll take it. But is it really that simple? Is the promise of money down the road the same as having that cash in your bank account today? This is the kind of question we need to answer not with a gut feeling, but with a clear analytical framework.
And answering that very question is our main objective today. We are going to learn the precise method for taking a promised amount of money from the future and calculating its actual tangible worth to us in the present. This skill, the skill of valuation, is absolutely foundational. It doesn't matter if you go into marketing, operations, or human resources. Understanding the value of future cash flows is critical across all business disciplines. You see, here's the core principle I want you to grasp. When we talk about money, the timing is just as important as the amount. You can't separate them. Thinking about a cash flow without considering when it arrives is like reading a sentence without paying attention to the punctuation. You'll completely miss the meaning. So from now on, the question in your mind should never just be how much. It must always be how much and when. This brings us to the formal economic principle that underpins our entire discussion. It's known as the time value of money. It's a simple but profound concept. A given amount of money is worth more right now than that exact same amount will be at some point in the future.
Now, you've probably heard this saying before, maybe from a parent or a grandparent. It sounds like a simple piece of wisdom, but in this classroom and in the world of finance, I need you to understand that this is not just a clever phrase, it is an irrefutable mathematical and economic law. A dollar in your possession right this second has more potential and therefore more value than the absolute guarantee of receiving a dollar 1 year from now. So let's break down exactly why that is.
The why really comes down to two major forces, which you can see here. First, let's talk about earning potential. If you have a dollar today, you can put it to work. You can invest it. You could buy a stock, a bond, or maybe reinvest it in your own business to buy new equipment. That dollar starts earning a return for you immediately. A dollar that you have to wait for represents a period of missed earnings. This is a crucial concept we call opportunity cost. By choosing to wait for that future dollar, you are giving up the opportunity to earn a return on it in the meantime. That foregone interest is a very real cost. The second force is purchasing power, and this is all about inflation. As time goes on, the general level of prices for goods and services tends to rise. So the dollar you get next year will likely buy you less than a dollar does today. Its ability to be exchanged for real things erodes. So when you wait for money, you're facing two headwinds. You're missing out on potential growth, and the money itself is losing its real-world buying power.
Okay, so we've established that future money is worth less than money today. The next logical question, of course, is how much less? To figure that out, we need a tool, and luckily we have one. It acts like a financial time machine, allowing us to take a value from the future and transport it back to the present day to see what it's worth. That tool is the present value formula.
The mechanism that powers this time machine is a process called discounting. Now, you're all likely familiar with its opposite, compounding. Compounding is when you invest money and it grows forward in time as it earns interest. Well, discounting is simply that process in reverse. We're taking a future sum and systematically stripping away the implied interest it would have earned over time to find its original value, its value in the present. To use this machine correctly, we first need to understand its components.
Let's start with the most straightforward piece. S represents the future value. This is our target number. In that problem with our client, the future value, S, is that $1,000. It's the specific amount of cash at a specific point in the future that we need to analyze.
Next up is I, the interest rate. But for our purposes here, we're almost always going to call it the discount rate. Now, of all the variables, this one requires the most thought. It represents that opportunity cost we just discussed. It's the rate of return you could reasonably expect to earn on your money if you had it today. What would you do with the cash? Would you put it in a safe government bond earning 4%? Or could your business use it for a project expected to yield a 12% return? Maybe you'd use it to pay off a high-interest credit card charging you 19%.
In that case, your return would be the 19% in interest you're saving. This rate is your personal benchmark. It is, essentially, the price you charge for waiting.
And finally, we have N, which is the number of periods. This is simply the element of time. How long is the wait? In our client example, N is 3 years. It's crucial to understand that the impact of discounting, just like compounding, is exponential. The longer the waiting period, the more that opportunity cost and inflation compound against you, and the smaller the present value becomes. And here's how all those pieces come together in a single, elegant formula. P, which is the present value we're solving for, is equal to S, our future value, divided by the quantity of 1 plus I raised to the power of N. Now, I don't want you to just memorize this. I want you to understand the logic. That whole term in the denominator, 1 plus I raised to the N, is the compound growth factor. It's the mathematical expression of how much $1 would grow to over N periods at a rate of I. So by dividing our future sum, S, by that very factor, we are literally reversing the growth process. We are mathematically unwinding time to find out what that money was worth at the very beginning, which is today.
All right, that's enough theory for now. We have our formula, we understand the components. It's time to put this financial time machine to work. Let's solve that problem from the beginning and figure out the true present-day value of that client's $1,000 promise.
So let's lay out our variables clearly, just as you should on any assignment or in any real-world analysis. Our future value, S, is $1,000. The number of periods, N, is 3 years. And for I, our discount rate, let's make a reasonable assumption. Let's assume that if we had the money today, we could invest it and earn a steady 5% annual return. That 5% becomes our opportunity cost for this calculation.
So, we just plug those numbers into our formula. Present value equals 1,000 divided by 1 plus 0.05 raised to the third power. When you punch that into a calculator, this is the number you get, $863.84. Now, what does that number actually mean? It means that the promise of getting $1,000 in 3 years has the exact same financial value as someone handing you $863.84 in cash right here, right now. This is incredibly powerful. It turns a vague question into a quantifiable answer. If another company offered to buy that future payment from you today for $875, you should take that deal instantly. If they offered $850, you should tell them no. You now have a data-driven basis for your decision.
Okay, great. Let's increase the complexity slightly. Business decisions are rarely this simple. They usually involve comparing multiple options with different amounts and different timelines. So take a look at this scenario. You have 2 offers on the table. Offer A is for $1,000 2 years from today. Offer B is for a little more money, $1,050, but you have to wait an additional year for 3 years total. And let's say the market has shifted a bit, and a more appropriate discount rate for us to use is now 6%. Which is the better choice?
This is exactly where present value becomes indispensable. It serves as a universal translator. It allows us to take these 2 different amounts from 2 different points in the future and compare them on an apples-to-apples basis, their value today. So for offer A, we calculate the present value, $1,000 divided by 1.06 squared, which gives us $889.99. Then we do the same for offer B, $1,050 divided by 1.06 cubed, which equals $881.50. And there you have it. The answer is clear. Even though offer B has a higher face value, its present value is actually lower because of that extra year of waiting. The financially superior decision is offer A. This is how you build a rational, defensible business case. All right. Now this formula is an incredibly powerful tool, but like any tool, it's only as good as the person using it. And over many years of teaching the subject, I've seen students make the same few mistakes again and again. So let's take a moment to go over these common pitfalls so you can avoid them in your own work.
Okay, first, and this is by far the most common error I see, mismatching the rate and the period. Class, listen carefully. If you are using an annual interest rate for I, then your period N must be expressed in years. If you're analyzing something with monthly payments, like a car loan, you have to use a monthly interest rate and N has to be the total number of months. They must always match. Second, please remember the order of operations from your basic algebra classes. You have to solve for the exponent in the denominator first before you do the division. A simple calculator error there will throw off your entire analysis. Third, don't mix up present value and future value. It sounds basic, I know, but under pressure, it happens. Always ask yourself, am I pulling money back in time to today, or am I pushing money forward into the future? And finally, be thoughtful about the discount rate you choose. I is not just a random number, it's your best educated estimate of future returns. Picking a rate that's wildly optimistic or overly pessimistic will completely distort your results and lead you to make poor decisions. It has to be justifiable.
So, if you take only one thing away from our discussion today, let it be this. Present value is not just a formula you need to memorize for an exam. It is a fundamental way of thinking. It is the language that allows us to compare opportunities across time, to value assets, to analyze projects, and to build sound financial strategies. Mastering this concept is quite simply a non-negotiable skill for anyone serious about a career in business.
And that brings us to a final thought I'd like to leave you with. You now possess the mechanical skill to calculate present value, and that is a significant achievement. But the real art and science of finance, the next level of understanding, lies within that single variable, I. How do we determine the right discount rate when the future is, by its very nature, uncertain? How do we properly account for risk? Should we use the same rate for a guaranteed government bond as we would for a high-risk startup venture? Answering that question is the next exciting step on your journey to mastering financial decision-making. Thank you for your attention.